Hey, here is the video for the first question, number 1, from your Unit 8 review. So you had a chance to read it, I'm sure. Pie chart analysis. Oh, I should have said in here, I wish I had said for you to ignore EDIS, to pretend there is no dissipated energy. So I didn't say that, but if you feel like you want to take a second to go back and think about it again, what your pies would look like, you could pause this video or whatever. So I'm going to do it with no EDIS. So if there's no EDIS, then my 3 pies going to look like, let's see. So at the beginning, when we're starting, it does have an initial velocity, so that means it's going to have EK, and it is like a little wind-up toy, so that means it's going to have EE also. I'm just going to, and it's at the bottom of the ramp, so it doesn't have any EG yet. So I'm going to go ahead and just make it look like about half and half, EK, and EE. And at the end, sometimes it's easier to do the ends first. Then it is up at the top of the ramp, and it's not moving anymore because it's got up to it stops, right? And also the spring is wound out, so it's all EG at this point. And then we just have to figure out, like, so what's going on here? Well, it went from no EG to all EG, so this is probably about half EG when it's halfway up the ramp. And then we got maybe the spring still has some, and it's still moving, but it's slowed down from what it was here. So something like that. All right. How about part B? I want to make an LOL diagram with positions A and B, top and bottom. So that's just making an LOL diagram for those there. So let's see, inside our system, I need the toy, and I need the spring in it, I guess. I don't know. If you thought the spring was part of the toy, I think that would be fine if you left spring out and you had toy there. And you need the entire Earth. Since there's no dissipated energy, I don't think that we need to put in the ramp, but it doesn't make it wrong if you do put it in there. So let's see, here I got EK and EE. So like 2 blocks of each of those, and then EG, 4 blocks there. So that looks good for my LOL diagram. Write the equation. That's just the equation that says what the diagram says. It says this plus this equals this. So EK plus EE is equal to EG. Right. And how much kinetic energy does the car have at the bottom of the ramp? This is just asking about the kinetic energy. So EK is equal to 1/2 mv squared. And, oh, by the way, I don't really know why in this document here the equations didn't show up. So you have them on your review, and they'll look like that. You'll have access to those equations when we do whatever our formative assessment thing. So anyway, you know that EK is 1/2 mv squared. So here that's going to be 1/2 times 0.045 times 2 squared. And with your trusty old calculator, you can find that that's 0.09 joules. And how much elastic or spring energy was stored in the car at the bottom of the ramp? Well, we're going to have to use our equation from C to do that. So EK plus EE is equal to EG. So I'm not trying to find the K or anything. I'm just trying to find this whole thing. So if I know this and I know this, then I can find this. So that's going to be, well, EK, I could do the 1/2 mv squared, but I did it here already. So let's erase that. And so I know that that's 0.09 plus EE is equal to EG, and EG is 10 times mass times height, and what did I get up to, half a meter, I think. And doing a little algebra, multiply that out and then subtract this over here, you're going to find that the EE is equal to 0.135 joules. And that's fine if you round that to 0.14, whatever. So there you go. There's number one. Try putting this video up, see how that worked.